Good morning. Last class we see about what are the basic steps and phases are involved in finite analysis. So first of all, these are the steps are very important whenever you are to analyzing the any complex shape or any method of modeling. Okay, these are the primary steps. Okay, so first of all, you have to do is discretizations, and also we have to find out the approximation functions. Okay, so then after that you can using these stiffness. We have to find out the stiffness matrix. The stiffness matrix we have to finding for the element wise. If you have any element, okay, if you take is a n number of elements, just we have to find out the n number of elements. After that, you can conclude in the total number of stiffness of the, you have to summation the how much stiffness matrix you have to find out the respective elements, okay. And also they have to find the concluding of the total matrix that is called as a load matrix, okay, is called as a force matrix. After forming the load total matrix, okay, you have to apply in the equilibrium conditions, and also implementation the what is the boundary condition we have to require. So after the boundary conditions only, we have to find out the unknown node displacement for the each respective nodes. Where is the unknown nodes of displacement is acted at the each node, we have to find out. Then calculating the stress and strain. Okay, based upon the problem requirements, we have to find out. So then what are the phases, we primary phases we have to move forward. So last slide we discussing the what are steps we have to carry out for the final analysis. Here there is a three phases we have to do. One is a pre-processing, solution, and post-processing. So what are the steps we have to doing for the pre-processing? So here the find element mesh. So I already told you what is a mesh. Okay, it's like a collection of a node is in form of a grid is called as a mesh. Okay, is developed by to divide the given geometry to subdomains for the mathematical analysis, and the material property are applied, and also the boundary conditions. So these are the functions we are doing for take as a pre-processing. So then moving for the solution. So what we are to taking for the solution means in this phase the governing matrix equations are derived. Okay, so we have to derive the summation of the stiffness matrix, and also you are to creating the load matrix. Okay, that is called as a governing matrix equation, or dividing the solution for your primary quantities is generated. Okay, so based upon your solution, based upon your boundary conditions, okay, so the next process or next phases we going for the post processing. So during the post processing, the last phase, okay, we are to checking the validations of the solutions generator and the examination value of the primary quantities. So we have to derive the primary quantities such as displacement, stress, and error involving is a carried. So these are the three phases or we are doing the any FEA process. The first one is pre-processing, solution, and post-processing. So see, pre-processing is like you give a load or mess or material property. And solution, where is your governing equation generator? Post-processing, based upon your requirements or based upon your primary quantities, we have to find out the unknown data like displacement, stress, and etc. So so we have to study the what is the meaning of FEA, and what are the types of engineering analysis, what are the steps we have to carry out, and what are the phases are required while doing the FEA analysis of the, okay. So these are the my advantages. So what are the advantages is called as a can readily handling for the geometrical shapes, can handling the complex analysis like a vibration, heat, fluid, fatigue analysis, structure analysis, etc. So can also handling the complex loads like a node-based load is like a point loaded, element-based loading like a pressure, thermal, and inertial forces, and last one is time of frequency depending loader. So can handling the complex restraints like intermediate structures can be also can be analyzed. Can handling the body compressed non-homogeneous materials, can handle bodies compressed non-isotropic materials like orthotropic or anisotropic. So special material effect is are handled by these like a temperature depends upon the properties, plasticity, creep or swelling, etc. So what are the disadvantages of FEAs? The specific numerical result is can be applying for this specific problem. So FEA is like a finite element method is applied to an approximation mathematical model for the system. So the source is called as the inherent errors. And the experience and judgment are needed to in order to construct the good finite element model. The powerful computer and reliable FEA software are essential. Input and output data may be large and reducers to prepare their incomes. The numerical errors such as limitations of the number of significant digits and round off occurs very often. The fluid elements were boundary yet defined and can be computed as using the bounding elements. So these are the softwares for using for the FEA. The first one is thing we know that ANSYS, Nastron, Patron, NISA, Display Third, LS Diana, HyperMesh, Katia, ROE, Creo, SolidWorks, and Cosmos. So these are the few software package of FEA.